So again, the word ratio tells us to divide. So we're going to take each y value divided by x. So -9 divided by -6. Let's just write down the decimal version of whatever that ends up being. I know that a negative divided by negative is going to give me a positive, so I don't really care about plugging those negatives into the calculator. I did anyways, and I got 1.5. Then if I take -6 divided by -4, let's see what I get there. I get 1.5. -3 divided by -2. Anyone want to guess what I'm going to get there? 1.5. The only time that doesn't happen is right here when I go 0 divided by 0. When I go 0 divided by 0, that's a problem. Calculator yells at you. Says you can't divide by 0. Okay, which is true. Hey, in this case, for what we're trying to pick up on, that 0, 0 actually doesn't make a difference for the conclusion we're trying to reach here. Okay, but all the others, 3 divided by 2, that's 1.5. And 6 divided by 4, that's 1.5. Okay, same thing's going to be true over here in the second table. -8 divided by -4. That's 2. So we're going to get 2 all the way down except for that 0, 0. And so what this brings up is a relationship between two variables, x and y, called direct variation. And so direct variation is a relationship that can be represented by the function y equals k times x. K is called the constant of variation. That's going to be a key part for what we will always look to identify. Now, if we take that equation, okay, so let's say y equals k divided by x, and I want to figure out what is my constant of variation, or k, what can I do to both sides to get k by itself? Do what to both sides? Well, isn't this right side? What's going on between the k and the x right now? Yeah, we want to divide by x, okay? They were already being multiplied, so we want to undo the multiplication by dividing. So if I divide both sides by x, we get that y divided by x equals k, which is our constant of variation. So looking back at the opener, when we took y divided by x, we got 1.5 every single time. That would be our constant of variation there. Okay, so we would say that y divided by x equals 1.5, where 1.5 equals our constant of variation. And so if we wanted our actual equation for that, where y was by itself, I would undo the dividing by x and just multiply. So if I multiply both sides by x here, I get that y equals 1.5 times x. Okay, and we could check that. If I take this x value of -6 and I multiply by 1.5, I should expect to get -9. So 1.5 times -6, boom, -9. 1.5 times -4, -6. Okay, so this equation illustrates explains every single coordinate pair we have in that graph. All right, so one last thing that I want to touch on here, direct variation. Basically, like the definition, if you were to look it up, that is not necessarily mathematical, is that as one variable gets bigger, or as one variable increases, so does the other. Okay, and then vice versa. Okay, as one variable decreases, so does the other. Right, and they're either increasing or decreasing at a constant rate. And that part is also important here for the direct variation. It's got to be constant. Hence the constant of variation. Okay. We have not done anything in graphs in here. This lesson relate to a couple things with graphs. I'll mention these, but that's going to actually be our first unit when we come back from break, is working with lines and graphs of lines. When we do that, we're going to actually be essentially graphing constant of variation equations, which are just linear functions. Okay, so again, this is just kind of looking ahead here, but the graph of a direct variation equation, y equals kx, is aligned with the following properties. It passes through 0, 0, and that's why in our table we always had 0, 0 as part of that. It needs to be 0, 0. If we don't have 0, 0, this does not follow constant variation, okay? It's very close, but not all the way there. And then the slope of the line is whatever that constant of variation is. Again, we haven't done much with lines, so I don't want to get too caught up in that what that slide is saying. So let's jump over to our examples. And it says, use the given information to write a direct variation equation and find the missing value. So the first thing that we actually want to come up with is the actual equation. And one thing that I write down, and this is a good idea when you go to take your test, is the equation for direct variation, which is y equals k times x. So I'm going to write that down as soon as I see the word direct variation, because now I can use some of the information and work to find the value of k. So it says, if y varies directly as x and y equals 7 when x is 3, find y when x equals 12. Well, we need to figure out k first. So I'm going to start with the 7 and 3. I'm going to plug 7 in for my y here. We do not know what k is, and then x is 3. So now I'm going to work to get k by itself by dividing both sides by 3. So really all I'm doing here is dividing the given y by the given x. So when I divide by 3, I get that k equals 7/3. Well, that is our constant of variation. And so now I can replace the k in my original equation with that given constant. And we can say y equals 7/3 times x. This is the equation for our direct variation. And the next thing we need to do is find y when x equals 12. So I'm going to say y equals 7/3 times 12. And then I'll let the calculator do the rest of the work from there. I'm going to go 7 divided by 3 when you do the division. Put parentheses around that division makes it, yeah, it doesn't really matter here. But a lot of times it will matter. Anytime you have a fraction, putting in parentheses in the calculator is a good idea. And we get that to be 28. Okay, so that is the second part of our answer. All right, well, I'm going to ask for you all to do number 2. Nothing changes, just the starting values. This time, though, you're going to find y when x equals 2. So find your constant of variation, identify your equation, and find the particular y value after doing all those things. Give you like 2 minutes. I'll tell you when. So again, not much different. Just want to make sure that we do get the same values here. So starting by identifying the constant of variation, where again, you just need to take the y divided by x. If you want to start with the equation like me, that is absolutely okay. If you know that you just need to take y divided by x to find that and get to 10 divided by 9, even better. Okay, that's a much quicker way to get there. So our constant of variation is 10/9, making the equation y equals 10/9 x. Then we need to figure out the y value when x is 2. So I plug in 2. We do get a decimal there. We'll continue to round that to 2 decimal places, and we'll call it 2.22. And if you ever do see, and I think a lot of us know this, that repeating decimal, you can put the bar above it. That just kind of tells us that the 2 is going to repeat forever, basically. All right. Questions here? Okay. Go and flip the page. Okay, once again, not much different here. Now we're going to be finding x given a specific y value. So the solving part will be a little bit trickier. But I want to start the exact same way. So I'm going to start by saying 10 equals k times the given x value of 3. So we're given that y is 10, x is 3. I can easily find my constant of variation from that. By dividing both sides by 3. So I get that k equals 10/3. And so now we're going to build our equation, which is y equals 10/3 times x. This is the equation, part of what we're looking for. And now our task is to find x when y is 30. So I'm going to let y be 30, and then I have 10/3 times x here. Now I'm going to show us a little trick to deal with this. Okay, a lot of you would probably, you see this fraction, you might convert it to a decimal, which is okay. And then you can divide by that decimal on both sides to get x by itself. Another thing that we can do here is if I read this out loud, that's 10 divided by 3 times x. The part that makes everything confusing here is the dividing by 3. So I can get rid of the dividing by 3 right from the start just by simply multiplying by 3. So when I multiply by 3, 3 times 30 is 90. That gives me 10 times x, and then I can go ahead and divide by 10 from there. And that gives me an x value of 9. Okay, the other thing that you could do here, so when I get to this point, I know, like, if that wasn't a fraction, let's say that this 10/3 was a 2, so you had 30 equals 2x, every single one of you would know that you need to divide both sides by 2. Well, we can do that same thing. I can divide by a fraction. I would just, for now, because we haven't covered how to divide fractions yet, just let the calculator do that work. So I could have also gone 30 divided by the fraction of 10/3. You just need to remember that the fraction of 10/3 needs to go in parentheses, and I get the exact same answer. Okay, so however you get there does not matter to me. Everyone do question number 4. Give you like 1 minute. I'll do the same thing. Okay. So again, not much different here. I'm going to start by letting 11 be equal to the constant of variation k times 4. Again, that's coming from the fact that y is 11 when x is 4. So my constant of variation is 11/4. Then using the equation that y equals 11/4 x, I can then plug the given y value in of 22 and work to try to get x by itself by first getting rid of that dividing by 4 by multiplying by 4. So 22 times 4 is 88. Then I can divide by 11 from there and get 8. Now again, if this last part, if you're like, wait, why is he multiplying by 4? Remember, one thing we could also do, this is 11/4 times x, is I can divide by 11/4. If I take 22 and divide it by 11/4, I get the exact same thing, okay, of 8. Okay, here's what I'm going to do. We just have a couple more examples. I'm going to go through just those real quickly, give you all about 5 minutes to finish the examples as well, and then you're going to get just about 30 minutes in here to get some homework done, which a lot of you need. Okay, and I'll talk about how we should prioritize that here in just a second. Okay, so let's look at 5 and 7, where it says identify the constant of variation. Now again, a lot of, with this whole unit, right, it's kind of been a mixture of topics. Understanding what it's asking is where we want to start, not just jump straight into what do I need to do. Okay, so identify the constant of variation in each equation. That basically implies this is direct variation. And so I'm like, okay, what do I know about direct variation? Well, it should be in the form y equals k times x. So if I can get these equations to look like that direct variation equation, I know that my number in front of the x is that constant of variation that I'm looking for. So basically, when we see this, our task is to get y by itself. If y is by itself, we can easily identify the constant of variation here. So this left side, number 5, is negative 2x plus 3y equals 0. In order for me to try to get y by itself, I'm first going to add the x's to the other side. And we did do this back in our solving unit. So the x's eliminate or go away, cancel. I get 3y equals 2x. Then to get y by itself, I just need to divide by 3. And so I get y equals 2/3 x, and thus the constant of variation, k, equals 2/3. Okay, that's what we'll be looking for when we do so. Right, number 7, again, the idea is the exact same, but this time I have y divided by x. What is your constant of variation equal to? Somebody can flip it over the front and look and help me out. K is equal to what? What does it say on the front there? K equals y and what else? Mia, what are you doing? What about y and x? Y divided by x or y over x? Yes. What do you notice about number 7? We already have y divided by x. That y divided by x, that is your constant of variation. It's negative 15/11. You don't need to do anything at all. If you wanted to keep it the same for what I just did and get y to be by itself, I can multiply both sides by x, and look what happens. When I multiply both sides by x, I get y equals negative 15/11 times x. Well, there's my constant of variation right there. Okay, so if we know that k is equal to y divided by x, we don't need to do anything. Okay, that is our constant of variation, whatever y divided by x is equal to. Okay, let's go through these last two tables, and then I'll let you all finish these examples and then get you all going on the homework. With our tables, if we want to determine if y varies directly with x, we got to see, does every y divided by x give us the same thing? So we're going to check, what is y divided by x? What does that equal? So 15 divided by negative 12. Is negative 1.25. When I take 10 divided by negative 8, see what I get? Negative 1.25. 6.25 divided by negative 5. Negative 1.25 as well. And it might seem like once we get it to work a couple times, we're good. But you actually need to check every single one. This can be kind of sneaky here. So negative 1.25 divided by 1. Well, anything divided by 1 is just itself, so that's still negative 1.25. Then negative 5 divided by 4 is negative 1.25. Okay, so do we have direct variation here? Yes, because y divided by x is always negative 1.25. So we would say yes, there is direct variation. You can abbreviate it dv. And the equation is that y equals our constant of variation times x. Okay, so you need to state yes or no and then give a reason why. All right, now I do want to talk about number 10 real quick because something weird happens here. When I take y of 2.5 and divide it by negative 3, I get negative 0.833. 3 divided by negative 2. Oh, negative 1.5. Never mind, we don't even have to worry about it. Is this direct variation? It's got to be the same every time. Okay, so no direct variation. Y divided by x is not constant. All right, you have 4 examples to work through on your own. And then that'll be it in terms of the notes, and we'll get you some time to get some homework done. Let's say like 3 minutes. We will check all these just to make sure we have these all written down correctly. Now it's good. It should be pretty quick. I bet you'll come back down. Okay. 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 Don't forget your notes. Why don't you take a homework as well? Okay. Okay. For all of you watching the video, you can check your work here with 6 and 8. Nothing weird that happens since we have y divided by x already. Your constant variation is just 11/5. Then for 8, I do 14ths times x. So thus the constant of variation is that number in front of x, which is 2/14ths. And lastly, 11 and 12. Taking y divided by x in both tables, I get the exact same value. For 11, I get -5, making your equation for direct variation y equals -5x. And for 12, when you take y divided by x, you get 0.4. So your equation is y equals 0.4x. All right, have a great day.